Hello, everyone, again. So it is 15:33 UTC right now on Tuesday the 7th, I think it is. Yes, it is Tuesday the 7th. So with this talk, we're talking with Alessandro from Meet Echo about a new project that they've got, which I'm really quite excited about from a personal point of view. But first off, I wanted to say thank you to all of our sponsors. So we've got our platinum sponsors, and they're Subspace, Daily, Element, and Mux. I've said this all week. Literally wouldn't have happened without them coming on board and saying, yeah, let's do it. Because ultimately they're the companies that come in first and ultimately kind of move stuff forward and allow us to kind of start planning. Then we've got our gold sponsors, Taloo, 100 milliseconds and Dite. Taloo have actually sponsored absolutely every single ComCon to date, which is absolutely fantastic. Then we've got Lowway, Sangoma, Millicast, and WebRTC Ventures. We've got our community sponsors, Jambones, Telecurve, and Pion. And we've got our AV partners. Our AV partners are brilliant. Again, the conference wouldn't have happened in the way that we are doing it without them. So we've got PSP, Millicast, Broadcaster VC, Subspace, Element, Mux, and Meet Echo. It's not a mistake in the fact that so many of those are platinum sponsors. So for now, I'm just going to pass over to Alessandro with the recording of his talk, and then afterwards we'll come back and do a little bit of Q&A with Alessandro live. See you in a minute.
Thanks, Dan, for the introduction, and hi, everybody. I'm Alessandro from Meet Echo, and today I'm presenting Janode, the Janus Node.js SDK. And first of all, some words about me, just a quick introduction. I am a WebRTC and backend engineer at Meet Echo. I am lucky enough to work in the same city where I was born and raised, that is the beautiful Naples in the southern Italy. And I joined Meet Echo in 2016 after a 3 years experience in an Italian telco. Like I said, my role here is a WebRTC and backend engineer, and my daily business consists in designing RTC application around the Janus server, enhancing the server itself with bug fixing and developing and stress testing. And of course, the most important part of my work is arguing with my desk neighbor, Lorenzo Miniera. And I already mentioned Janus. I think that many of you already know it. It's one of the most popular open source WebRTC server, and it has been conceived with a modular architecture. And that means that it has a well-defined core that implements all the functionalities needed for setting up your connections and relaying RTP packets. And then there are the plugins that take those RTP packets and implements the logic for the applications in Janus. So for example, if you want to use Janus as an SFU, you have to deal with the video room plugin. Or if you want to use Janus for one-to-many broadcasting, you need to deal with the streaming plugin. And for interacting with the core and the plugins, Janus has two kinds of API that are JSON APIs. Those are the Janus API that is used for the client. So if you need to interact with the plugin, establish a peer connection, and so on and so forth. And the admin API that is needed instead for administration purposes. And in order to use those APIs, you need to create a connection with the server, and that connection must be done over a transport. And Janus support multiple transport. The most used ones are, for example, the HTTP long pond, WebSocket, and RabbitMQ transport. So in many applications built around Janus, often you do not have a direct communication between Janus and the browser. Often there is a middle layer between them in the signaling plan that is referred as adapter, wrapper, controller, and things like this. And I try to make a list for the reason why you should use an adapter and not getting the two endpoints connecting in a straight way. First of all, there is a security reason for that. In your application in production, you may not want to let clients invoke any kinds of API over the Janus API. For example, in the video room plugin, you do not want clients to have the chance to call the API for creating or destroying a room. And actually, Janus has some mechanisms in place for protecting such dangerous calls, but in the end, you rely on secrets and passwords. So once that secret or password is guessed or spoofed or leaked, basically your application is in danger. By putting an adapter on the signaling plat, you're basically filtering the kind of requests that the client can make. Then you may want to customize your API. For example, you may want to enrich an existing API to add some parameters or just simplify it by setting some defaults, or also maybe merging multiple operations into one operation to simplify the API for the client. And then from the most general perspective, you may need to deploy an application server in your architecture, maybe because you need communication with other backends during the signaling, or maybe you need to update some kind of distributed status while dealing your application. And we see an example of this, how we do this in our virtual event platform later. So this is a picture of how an application using an adapter looks like. There is a controller on the signaling plane, and it is talking a custom version of the API towards the client, or maybe the Janus API itself, but in a shrinked version. And then it's talking with Janus API with the Janus instance. Of course, the media is still flowing end-to-end because that is part of the WebRTC protocol. And that's in an effort to create a standard and common adapter for Janus in the Miteco environment that we developed Janode. Janode is a Janus API and admin API adapter that supports both node.js and browser. And actually, it was born as a personal project in the 2016 when I joined Miteco, and it was used by me basically to understand how the API worked. Then it evolved in what is today, that is a standard adapter used by Miteco in basically any kind of application from consulting project to our RTC platform. And you can find the library on NPM and also the code on GitHub. What we try to do while developing Janode is trying to stick to some key concepts. First one is try to stay close to Janus abstraction. What I mean by that is preserve the difference that there is between the core and the plugins. So shift Janus as a core, Janode as a core, and that is the part that wraps the Janode core, the Janus core. And the same for the plugins. Then we also try to keep the abstractions of connection, sessions, and handles in Janus. So we have a one-to-one mapping from those abstraction to the abstraction in Janus. Then we try to keep the number of dependencies very low, ideally 0, but it's not zero now, but because there is something that is not natively available on Node, for example, the WebSocket clients. Then we try to keep the library stateless. We do not want to store any status while executing the wrapper. Also, we try to somehow simplify some difficulties in the Janus API. For example, in the Janus API, there is a distinction between synchronous and asynchronous requests. That is something that we wanted to smooth, to make it more simple for potential users. So you have, for example, an API for carrying on an asynchronous request, and that will return once you have the final event that closest to the transaction. And in terms of language, it is written in a modern JavaScript, so it makes use of advanced syntax like await, async. It is ready for ESX modules, and it has absolutely 0 callbacks and just events. So it is something that I think it's it can be considered a modern JavaScript library. And this is a picture of how the library is organized. Basically, the user needs to use the Janode API to create a connection with Janus. And currently, the only transport supported is the WebSocket transport. And once you get the connection, you can have the session, the handle, still using the Janode API. For the plugin parts, instead, like I said, there is another API that every plugin in Janode must expose, because the plugin is basically an extension of a handle. And now I just want to show you a quick example of how Janode works. This is an hello world, very simple. You can find the same code on the GitHub repository. This basically, you start by importing the library and the plugin as common JS syntax, as usual in Node.js. And once you get the Janode interface and the plugin interface, you start by creating a connection. And then with the connection, you can get the session. And with the session, you can attach a plugin, getting back an handle. Notice how those are all promise API. So you do not want to know what is behind these codes. So you just wait for the result, and you don't know if this is an asynchronous request or a synchronous request. The important thing about the plugin here is that what is returned by the require of the plugin is what we call a plugin descriptor, and more on that later. Once you get the handle, you can register the listeners on this handle. Some of the events are emitted from the core, like for example the WebRTC app event that notified the users that the pre-connection has been is working now, and other events are specific to the plugin. In this case, the result event is specific to the echo test plugin, and also you can also use the APIs that are provided from both the core and the plugin itself. In this example, we are using the trickle API that is provided by the Janode core to send a trickle to the Janus plugin. And also we are using start API that is instead a custom echo test API that is used to basically start a session with the echo handle and carry on the negotiation. And it returns, in this case, the JSON answer. So talking about plugins, there are already some plugins implemented on the repo, and the most used ones are Streaming, Audio Bridge, and Video Room, and those are already present on the GitHub repo. The Audio Bridge in particular is in Janus, the MCU for the audio, while the Video Room is used in Janus for the SFU. For writing a new plugin or maybe creating a customized version of an existing plugin, you just need to extend the handle class in Janode and override the handle message method that basically implements the logic to handle any events incoming from Janus. Then you should implement custom methods. For example, we saw the start method on the echo test that users can use to simplify the interaction with the plugin. And finally, once you got all of this, you need to export from the plugin what we call a plugin descriptor. And it must export an object with 3 fields. The first one is the ID. That is the same ID that will be used while attaching the plugin to Janus. Then there is the handle class that is an object, basically the class that you have implemented extending the handle class, and an event field that contains an object with the list of all the custom events that the echo test plugin, for example, might export. And now I want to show you a quick demo how Janode is working on my machine. And I want to show you the echo test application running first on Node.js and then on the browser. So let's switch to my shell. I have here an instance of Janus that is already running on the top part. And here I'm in the echo test example that you can find on the GitHub repo. I just keeping the parts about building the examples in the library for brevity. So I'll start by running the echo test example here. And you can see that it has been connected with the local instance of Janus. So now what is happening is that this application is basically launching a server that is listening on the port 4443. On that port is hosting a static web page and also a Socket.io server that is a common library used for creating socket-like connections on both WebSocket and HTTP long pole. Now I'm opening a page on the application. Forgive me for the ugly HTML, sorry. There it is. I've started the web app. This is my remote feed being sent back. And if we inspect the WebSocket here, we can see the message exchanged between the application server and the browsers. This is not the Janus API at all. It is indeed an API that has been implemented in the EcoTest application, and the browser in this case does not know anything about Janus. Instead, if we, on the other hand, test what happens in a browser when using the library in a browser, we just can refer to the other example that is present on the GitHub repo. That is the one under the browser folder. I have included a bundle script here that basically creates a bundle for the web app using Browserify, and it also, for convenience, installs it under the Apache static website folder. By launching the script, we are just creating a bundle and installing it under the Apache folder. So now we just need to go to the my local Apache. And starting the demo here. Okay, so now what is being exchanged over the WebSocket is the common Janus API, like we see, but the difference is that the user that is programming the EcoTest application is using the Janode library inside the browser, so he must not know the specification of the Janus API, just uses what the Janode API provides. I guess that's it for the demo. Okay, now back to our presentation. Now I want to show you some examples of how we use it, the library in production or for some internal tools in Miteco. The first example is the Janus stress testing controller. This is an application that is used in couple with JATAC. This is an internal tool that we have in Miteco. Basically, it's a kind of client version of Janus that must be instructed through the JATAC API on how to carry on a negotiation and set up connections and things like this. So the Node.js application built on Janode here is trying to running a testing scenario that the users will implement. In this testing scenario, it is written how the negotiation must be carried on. So, for example, if you want to test the video plugin, there is all the logic needed to make the JATAC instances enter inside the video room, publish the streams, or subscribing to other streams. And this can be done over a huge amount of instances, a configurable amount of instances and sessions. So this is basically a tool that we use for load testing the plugins or also other applications built around Janus. When the test ends, the controller also create a report where we can check the success rate or also some parameters about the quality of experience. Another example of how we are using Janode is the Janus WHIP layer. For those who may not know, WHIP is the WebRTC HTTP ingestion protocol that is named the WISH in the ATF. Basically, this is an attempt of standardizing a way to publish a WebRTC stream in a WebRTC server, and this is done by using HTTP. So, for example, if you want to set up a quick connection with a WHIP-capable server, you need to send an offer in a post, and you get back an answer in the response. Or if you want to send requests, you need to issue an HTTP patch request and things like this. Of course, in the end, the media setup is still end-to-end, like needed by the WebRTC specification. And what we did is this simple WHIP server that is currently hosted on GitHub. And the role here of the node.js application using Janode is to basically convert the calls from wish HTTP to the request to Janus. So, for example, if you want to create a WHIP session, and we're using a Janus video room for this, that post means that we need to publish a user inside the video room, and that is taken into account by the Node.js application using Janode from this. Of course, the media is still flowing end-to-end, and this one way, because, like, say, the WHIP is used for the ingestion, so for send all repeat connections. And finally, this is maybe the most important application that we have in production using Janode. If you remember this picture, this is from the ConCon 2020, and it has been taken from Lorenzo, from the Lorenzo talk about how we developed a new virtual email platform for the after pandemic world. And basically, the architecture proposed is an architecture where active speakers need to publish themselves in video room nodes, while passive users, so subscribers, need to use streaming nodes to view that feeds. And the media is being exchanged from video room to streaming in a sort of a cascade architecture, thanks to the functionalities of the RTP forwarding and the video room plugin. But if we could zoom on any node of that architecture, like for example a Janode, like for example the video room node, we could see that any node is basically a Docker instance that contains a Janode application and a Janus server, and those are co-located on the same Docker instance. And here the Janode application is in charge of many functionalities. First of all, it has an HTTP interface that is used for getting requests from a platform manager, that is the entity that orchestrates the whole platform. It is needed, for example, to allocate resources on Janus needed for publishing users on it. So if you want to publish in users, the manager needs, for example, to create an handle on Janus, or create a video room, or start an RTP forwarding for that new feed, and that is done thanks to HTTP interface that is used for this kind of private signaling. Then there is an interface used by publishers that is based on Socket.io, like we saw in echo test example, and that is needed for publishers to publish their media that flows one way, because this is a send-only connection. Finally, this node only has some responsibilities in updating the distributed status of the architecture. We use for this distributed status the etcd framework, that is very used in the Kubernetes application, for example. So we have also an etcd client inside that Janode application that update the distributed status, and that status contains information like, for example, the load of the machines, the number of peer connections, the active feeds, the active forwarders, and things like this. And that status is constantly monitored by the platform manager that might take some reaction to some status changes. And that reactions always translate in HTTP calls to other nodes or to the very same node that generated the change. In the end, what is produced after a user that is being published is the RTP forwarding of its feed on the tree architecture. So that RTP forwarding will reach a streaming node. And the streaming node is very similar in the concept to a video room node, in meaning that it is always a Docker instance that is holding a Janode application and the Janus instance. Again, the Janus streaming application has three interfaces: one to get requests from the platform manager, one to make the user subscribe to the active feeds, and one interface to update the status on the etcd distributed key value storage. So now, what's next on the library? What are the next steps? It is still not complete, of course. There are some features that need to be added. For example, the most important things is the multi-stream support. That is something that will emerge on Janus sooner than later, and will probably impact the plugins API for the most part. Then there are some missing APIs on the existing plugin that we want to implement. We just focused on the ones that we used for our own applications. And also I'm considering to add some other transports that are currently missing. Like I said, we just support WebSockets at the moment, but if there is a demand for that, we could add also other transports. In general, then we would like to improve the code base also by adding some tests that are totally missing, unfortunately, on the repo. Also, trying to get a better documentation. I use a JS talk for the documentation of the library, but I didn't really like the experience. Maybe I see that a lot of people today is using TypeScript to document the Node.js project. Maybe it's worth changing that to TypeScript. And finally, I'd like also to convert the common JS module into ES6 modules. This is something that should be done quite quickly. Could be done quite quickly because the project is already formed to make this conversion. I'm still holding this transaction because, if I remember correctly, this is only supported from Node 14. And that is quite a recent version. So I don't want to leave back people using older versions of the environment. And finally, every suggestion is very welcome. You get the code on GitHub, read the code, open issues, pull requests, and we're more than happy to analyze them and give a feedback. And I guess that's it. Thank you very much for your attention, and I'm ready to answer all your questions.
Welcome back, everyone, to me, live. So I'm going to bring Alessandro straight in because I know that he's got a small update. We recorded this talk I think three weeks ago, and so Alessandro's got a small update. So I'm going to pass you over to Alessandro, and then we can have a little chat after that update.
Okay. Thanks, Dan. Hi, everybody. This is just a quick update about the progress of the project. Since we recorded the talk, we kind of addressed it two other points of the what's next slide. In particular, we submitted one pull request for implementing a Unix socket transport via datagram sockets, and another pull request for basically switching to ES6 modules. So we are now ready for the future module standard. Okay, thanks.
So, I mean, obviously, I was there when we did this recording a couple weeks ago, and I remember seeing on that slide convert to ES6, and I was like, yes, absolutely, we need to do that so that it's easier to bring into how people now use Node and Webpack, etc. So that's really great. I was saying in the chat during the talk, I'm so excited about Janode and having kind of a official SDK to do signaling and API talking to Janus, and it will speed everything up when it comes to doing a new project. Like, the demos are great from a demo perspective, but like at the end of the day, we don't write callback code anymore in JavaScript, and so like just trying to like, especially when there's something new, you go, oh, how did the Meet Echo guys do that? And so you read through the code, and then it's callback, and so you can figure it out, but then you end up having to rewrite it for whatever application you're running. So I'm super happy to see a modern JavaScript SDK around Janus that's going to get maintained into the future. Because there's other ones out there. There's Mini Janus. I use Mini Janus. I use Video Room plugin, which is also on npm. But they're all slightly not loved anymore, and missing some features and missing new things. So yeah, super excited to see the changes coming soon. So what I guess my main question to you is, what do you think is coming next? Like, is multi-stream the next thing on the list? Because like that's ultimately Janus, the project, is so close to having multi-stream as version 1 or whatever is decided upon in that respect. Is multi-stream next in the SDK or
yes, yeah, I guess that's the next big thing. We need to implement multi-stream because I think that many applications in the next future will make use of multi-stream for all the advantages that we know. So yeah, I try to focus my efforts on that task.
Right. I have a minute every time. I remember I think it was the very first ComCon that we ever did 4 years ago, and Lorenzo did a talk about multi-stream in Janus, and then came around, and then this year I said, this year could be the year that you put in a talk into ComCon and say multi-stream's done, and he was like, no. I'll talk about something else. So I can't wait until multi-stream is the de facto standard, and so the SDK can follow that, etc. So I want to say thank you, and I want to say thank you to Meet Echo for being technical AV sponsor of ComCon and driving everything forward with the NDI plugin for Janus. If people don't know what that is, then they should tune into there's a broadcaster VC session on Wednesday, and where I talk about that. So thank you very much, Alessandro, and that's it. That's it for this session. Unless there's anything else that you wanted to say, Alessandro.
I just wanted to say thanks for letting me present Janode here at ComCon. Thank you very much.
You're more than welcome. Thank you so much. And that's it. Thank you very much. And if you're watching on demand, then on YouTube, then make sure that you like the video, you subscribe to the channel, and you press the little bell that tells you when we put new videos up. And where were you? You should have been here on live. And all the people watching live, Thank you. So we'll see you soon later on today for another session.